Hey, my Ninja Warriors, welcome to yet another Power Packed session. We are live, and yes, today is the day that you are going to remember forever. Yes, so 12th mathematics and 10th mathematics CBSE are 2 days which we are going to remember forever because I remember both the days of mine. So yes, we are going to be absolutely positive about today. We are going to be absolutely enthusiastic about today. We are going to be absolutely happy and we have to feel great today, right? So on this note, you should like the session and you should let me know whether I'm perfectly audible and visible so that we can quickly start. And in 30 minutes, we'll try. In 30 minutes, we will revise all the formulas, all the important CBSE board. Yes, yes, yes. Vanakkam, vanakkam, vanakkam. Yes, yes, yes. All right, all right. Yes, everything is gonna be good. Okay, you just have to feel good. Today, you feel good. Have a nice shower and then go to your CBSE board center and be happy. 3 hours you are going to enjoy. You are going to have fun. And yes, you are going to get nervous, stressed out as well. But that's a part and parcel of mathematics paper, right? Yes, yes, yes. Okay, okay. All right. And be happy. 3 hours. You're going to enjoy. You're going to have fun. Yes, you're going to get nervous. Okay, I guess yes, audio quality is a little bit not great because I'm using my laptop's mic. So yes, 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 yes. So let's start. We have 30 minutes and yes. So let's just focus on the revision part. Let's not focus on mic quality. Start with relations. From relations, for sure, you are going to get a question from this particular section, which is reflexive, symmetric, okay, reflexive, symmetric, and transitive. These three things are important. Let's understand. So suppose you are having set A 1, comma 2, comma 3. Relation will be that relation in that you are going to have all the ordered pairs involving 1 comma 1 and it should have 2 comma 2, it should have 3 comma 3. No ordered pair should be left. A comma A should be there. Okay, all right. Yes, 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 this is reflexive. Now symmetric relation says if 1 comma 2 is in my relation, 1 comma 2 sits inside my relation, that 2 comma 1 should sit inside my relation, otherwise it won't be symmetric. If 1 comma 2 is not there, we will not check for 2 comma 1. Right? What is transitive? So transitive says if 1 comma 2 and 2 comma 3, if 1 comma 2 and 2 comma there inside my relation, that means 1 comma 3 inside my relation, otherwise it is not a transitive relation. I guess these three things are clear to us, right? Okay, and this is your anti-symmetric relation, which is not that important, but still I have mentioned this. And this is your identity relation. Okay, identity relation means that each element should be connected with every element. Okay, all right. Yes, yes, yes. All right, so this is reflexive, symmetric, transitive. And if a relation is all three, you can see if a relation is equivalent, symmetric, and transitive, that means that that relation will be equivalent. Symmetric, reflexive, transitive means equivalence relation, right? Now, one function, very important. One is also called as injective function. One is also called as injective function, and onto is also called surjective function. Okay, now what is one function? Basically, one to one, one to one, one to one. What is opposite of one? Or what is a function who many one? So left side you have multiple, that would be many one. Now what is onto function, ma'am? Now, what is codomain? What is range? Please explain one more time, ma'am. So basically, if you can see this, this is your set domain. Set B is nothing but codomain, right? This is your codomain. And what is range? Range. So over here, can you see both the elements are connected? That means range and codomain both are equal, so this is onto or subjective. But can you see in this particular case, codomain is 1, 2, 3, complete set, right? But range is only 1 and 2, right? Range is 1 and 2, codomain is 1, 2, 3. That's why both are not equal. So we cannot call it as an onto function. So this is not onto, hence not subjective, right? Now, some of you how to write number of functions, so it is very clear. Okay, so suppose you are having four elements in set A and you are having elements in set B, right? This is A to B. So you are looking for number of functions, total number of functions from A to B, right? Total number of functions from A to B are 4. So set B raised to power set A, right? Set B raised to power set A. Okay. All right. Clear? I hope this is clear. Set B raised to power set A. Okay, so this is total number of functions. Okay, all right. Now, if you need to find whether your function is 1, 1 or not, right? Whether your function is 1, 1 or not. So for that, yes. So can you see in this particular case number 1? Can you see over here? Set A is having 4 elements, set B is having 3 elements. If I try to make this as one function, so first element gets connected with this, second gets connected with this, third gets connected with this. This element will be left out, which is not at all allowed. This 1 function out of this situation where your set A elements are more than set B, it is not at all possible. So what should happen, ma'am? Then what is the case? So basically, so we can now form 1, 1, or it should be less, right? So these are 2, this is 3. Now also we can find. So can you see? So this is, that means set A elements should be less than or equals to set B elements. I hope that this is clear, right? I hope that this is clear. Okay. All right. Yes. Okay. Then how to find number of injection or number of 1, 1 function? If you find number of 1, 1 function will be nothing but, okay. So number of 1, 1 function will PM, right? NPM. So over here in this, if you wish to find number of 1, 1 function, that will be 3P2. So basically 3, right? 3 will be number of elements of set B, P2. All right. Okay, clear, right? So this is what was important. I told you what is important. Relations and functions may only this is important. Now quickly let's understand the inverse trigonometric function. Inverse trigonometric function. Voice nicely. Okay, anyway. Yes, so inverse trigonometric function, let's understand. You know that the sine function, sine theta, y is equals to sine x. So you know that x, the domain over here is all x, you can put anything, and range will be -1. It becomes reverse. So for inverse function, the domain x will be what? -1 to 1. Same goes with cos inverse x -1 to 1. Okay. So y is equals to sine inverse cos r minus -1 to 1, r minus -1 to 1. Tan inverse, cot inverse, both all real. Okay. All right. Now, the range, if I talk about the principal value of this, so y x is minus pi by 2 to pi by 2. And same goes with cos inverse x, except the fact that cos inverse x cannot be equal to 0. So these go, sine inverse and cos inverse x goes together, right? Then cos inverse x and sec inverse x go together. Sec inverse cannot be pi by 2 only difference. Okay. And then tan inverse and cot inverse. So these two are different, by the way. So tan inverse is open bracket minus pi by 2 to pi by 2. And cot inverse is open bracket 0 to pi. Please note down, please remember. Please note down, please remember. Okay, I can see that you guys are not happy with the mic, but it's not the mic. My mic is fine. I have changed 3 mics. It's some issue, technical issue with the laptop. Okay, all right. Okay, please bear, please bear. Okay, all right. So here are some properties might help you, and the properties are okay. So can you see that sine inverse x, right? Cos inverse x, tan inverse x, and cot inverse x. So these all the trigonometric ratios become inverse or reciprocal. So sine inverse x will be equals to cos inverse 1 by x. Cos inverse x will be equal to sec inverse 1 by x. But tan inverse and cot inverse slightly different. So tan inverse x will be equals to cot inverse 1 by x. But here is the catch. Over here, it is only possible when x greater than 0. When x is less than 0, cot inverse x 1 by x minus pi. Okay, all right. Yes. And again, cot inverse x is equals to tan inverse 1 by x greater than 0. So here is the catch. This is actually a little bit tricky. Okay, only when x greater than 0, but if x less than 0, things get changed. Okay, so here are a few properties again. Sin minus x, if I talk about sin inverse minus x, sin inverse x. Okay, then tan inverse minus x, again minus tan inverse x. Cosec inverse minus x will be minus cosec inverse x. But rest three can be different. So there are two categories. Sin inverse minus x, tan inverse minus x, cosec inverse minus x give minus sign. But cos inverse, cot inverse minus x will give you pi minus pi minus pi minus. Right? Yes? Okay. All right. I hope that this is fine. Now this is again another property. Please start writing. Sin inverse x plus cos inverse x is pi by 2. Of course, x belongs to minus 1 to 1. Cosec inverse x plus sec inverse x is also pi by 2 within the domain. And tan inverse x plus cot inverse x is equals to pi by 2 within the domain. So these are the important properties because ITF, you know, is having very less weightage. So they cannot give you very, very difficult questions. Just the basic question. So in ITF, majority, what you need to remember, this table. Only this table, if you remember, you are going to be absolutely fine. Okay? All right. Yes. All right. All right. So now let's talk about the differentiability. So here are the formulas of differentiation. So you know that a derivative of x is 1. So these derivatives, I know that you know. Derivative of tan x is sec square x. Okay. Derivative of sec x is sec x tan x. Now this is reverse process of integration as well. So you know the integration and derivation, right? Yes, cosec x is minus cosec x cot x, and what else? What else? Okay, so these two are forming pair. Sin inverse x derivative is 1 upon square root 1 minus x square. Cos inverse derivative is minus 1 upon square root 1 minus x square. Right? Again, tan inverse and cot inverse hand in hand. So over here it is not written, but let me just write it down. It is this. Okay. And rest of the differentiation, you all know this is all the formulas. Please have a look, have a glance of this formula, right? And you know how to do logarithmic differentiation when it happens. F raised to power x raised to power g raised to power x. You take log both the sides. You take log both the sides and then you need to differentiate, right? Yes. You know the chain rule as well, right? Okay. Any formula which you are not aware about, have a look, right? All formulas you know. Okay. All right. So this is your differentiability. Now let's talk about continuity. What happens when a function is continuous? So basically, f of a will be equals to limit of that function at x tend to a. This you should know. Only this about continuity. Continuity is sorted out. Okay. All right. Yes. algebra of continuous functions. So if you are given the function, then sum, product, difference, and the composition as well is continuous. Okay, when two given functions are continuous, then their composition g of x, f of g of x is also continuous at x equals to 3. Okay. All right. Now, one very important thing, that for differentiability, let me just write, for differentiability, LHD should be equal to RHD at x equals to a. What is LHD? Who is going to tell me? Of f of a minus h minus f of h minus f of a upon minus h, limit h tend to 0 plus. This is your LHD. What about your RHD? Who is going to tell me? F of a plus h minus f of a upon h. Right? This is very important for the differentiability. This can actually be a trouble for you. Yes, continuity, I know you will do. Differentiability, especially this first principle, LHD, RHD, this can be a trouble for you. So please see an example from NCRT in the very last moment. Okay. All right. Okay. All right. Okay. So this is how it is. And yes, that's it. I guess no need for me. And yes, mean value theorem actually is in your syllabus. Okay. So mean value theorem, what does mean value is that suppose there is a differentiable and continuous function in this interval a comma b, right? Then what we can say is f dash c. What is c? C lies between this interval a comma b is equals to f of b minus f of a upon b minus a. That's it. This is your mean value theorem, right? Okay. All right. Cool. Okay. Now let's talk about the indefinite integration. So some formulas related to indefinite integration, let's understand, right? So derivative of integration. So basically, okay. So we use this term, integration. Understand this. Integration, primitive. Primitive also they can say. Antiderivative. These three terms are absolutely same. And one more term. Here your fx is nothing but integrand. So they can play with the words as well. Fx is your integrand, right? Okay, clear? Okay, now integration by parts. So first function into second function using Eilert rule. So inverse trigonometric function, if you mark it as the first function. Then logarithmic function, if you see again, mark it as the first function, right? And then this is the order. So integration of product of these two functions, second का integration minus integral of derivative of first, integral of second, and overall integral by parts. Okay. All right. Yes. Here are the formulas one by one. You can go through the formulas. Integration of a constant, integration of constant multiply function, integration of sum of or difference of two functions, integration of x raised to power n. Please remember one mistake, one common mistake I have seen, that okay, if you wish to integrate this, how will you integrate? Who is going to tell me? Ma'am, 2x plus 1 cube by 3 plus constant. Yes. Is it correct? What's the mistake? Who is going to tell me? Who is going to tell me? What's the mistake in this? What's the mistake in this, guys? Yes, there will be a 2 as well. Divide by 2, right? So please do not forget that. Okay, all right. Yes, 1 by x integration log of mod x. Integration a raised to power x log a. This integration you know. Sin x integration is minus x. Remember the minus sign. Cos x integration is sin x. Sec square x integration is tan x. Cos x square x integration is minus cot x. Sec x tan x integration is sec x, right? Cosec x cosec x cot x integration is minus cosec x. Remember the formula. Okay. Now tan x integration is either log sec x or minus log cos x. Remember the mod. Cot x integration is log of mod of sin x. Sec x plus tan x, and this will be log of sec x cosec x minus cot x, right? Square root of 1 minus x, square root of, okay, sorry. Integration of 1 upon root 1 minus x square is sin inverse x, and the negative of this will be cos inverse x. This integration is tan inverse x, negative of this will be minus cot inverse x, and 1 upon x square root x square minus 1 is sec inverse x, or negative of that will be cosec inverse x. Okay. All right, some more formulas, important formula. Okay, one important thing actually. Can you see 24 and 21st? In this formula, 1 by a clearly is here, but in here you don't have 1 by a. Please remember that this sin inverse formula is not having 1 by a, right? This formula is also important. Please do not remember this formula. Only 1 upon x square minus a square. 23rd formula you can create by minus sign. So dx upon x square minus a square log of x minus a upon x plus. Okay. Okay. Probability mein you will have a question Bayes theorem, right? And conditional probability. Right? Then we have these two formulas. Okay, easy peasy. Right? 1 upon x square plus a square ka root, ya 1 upon x square minus x square ka root. So log of mod of this, log of mod of this. Okay. All right. Then this formula is very, very important. Square root of x square a square minus x square. This happens when they ask you about something like that. So y will be square root of 4 in area under curve. So please remember this formula nicely. Write down nicely 2-3 times so that you don't forget about it. Okay. All right. Yes, there are some important substitution. The moment you see square root of a square minus x square, you put x is equals to a sine theta, right? The moment you see square root of a square plus x square, you see is x is equals to a tan theta in plus. And if you see x square minus a square, you put a sec theta. Okay. All right. Clear? Partial fraction. Yes, this is important, guys. This is important. Yes. Krishna, I already made a video yesterday. You didn't see kya? Topper's answer sheet. The first 5 minutes, first watch that video, first 3 minutes, I already spoke about time management, everything. So that Topper's answer sheet video, I specifically told that how to manage time in first 5 minutes. Please watch that video. Okay. Yes, Robin is absolutely right. That's what I told you in that video, that high weighted section you have to select. There is no one universal section which you all should start with. Okay, that's what I told you in that video. Okay, so now the moment you have two linear factors, the moment you see you are having a repeated root in the denominator and the repeated root, sorry, this is a, yes, x minus a square. The moment you see again in the denominator, you will 1 upon a upon x minus a, b upon x minus b, c upon x minus c. Again, the moment you write one repeated root, so yes, one linear root is alag and this is single root and repeated root. The moment you see one linear function, one expression and one quadratic which you are not able to get. So again, linear is sorted a x minus a, but always think about the quadratic. So numerator of the quadratic will have that linear function. Okay. All right. Now definite integration. Let's talk about the properties related to your definite integration. Okay. Properties related to definite integration. So change of variable, if you do, it doesn't make any difference. Okay. If you wish to reverse, what reverse? The limits. What you need to do is take the sign outside. Okay. And I already told you so many times, the moment you solve a question like this, okay, And you put, okay, ma'am, now we know 1 upon x, and this is 1 to 2. 1 plus x square is equals to t. Do not forget to change the limits. Right? Now 2x dx will become dt. This is d. What about the limit? The moment x is equals to 1, you get 2. The moment you put 2, 5 to 2, now limits will be changed altogether. Right? Clear? Okay. Yeah, I guess if you are section 2 now, you can start with section 2. For safe side, if you feel that the paper is difficult, and I am confident about section B, because section B is having 2 marker questions, and so in the the first 3-4 pages should be neat and clean, first impression, so you can definitely start with that. Okay, all right. Do not take stress from where to start. Okay. All right. But just think, okay, I'm confident about this. Take the decision, do it. Go ahead. Now break the limit, right? Breaking of the limit. Can you see A to C, C to B, right? You need to break the limits. Okay, so property 3. Now this is King's property. Absolutely, absolutely important. Always, always, if you feel that gonna be with the help of King's property, now what you can do is you can write the King's property and highlight it with the help of the box. Okay. All right. Now this property. This is actually not a property. Yeah. This property. Let's focus on this. Yes, minus a to a. If a function is even, so that will be twice 0 to a. If a function is odd, minus a to a will be 0. Even odd property is odd. Right? This is your Queen's property. Let me just write the Queen's property over here, because writing will actually make you remember 0 to 2a. Fx dx. If you wish to change the limits, so 0 to 2a from 0 to a. So 0 to a fx dx plus 0 to a f a minus x dx. This is your Queen's property, right? Queen's property. And last but not the least, yes. So this is the extension of Queen's property. No need to remember for your boards. This is fine. Till here it is fine. Okay. All right. Now, matrices and determinant. Okay. Matrices and determinant. This is your matrix. What are important properties? Okay. Let us quickly straight away. Let me go to the important properties. Yes. This is the important properties. A transpose A. Okay. And whenever you see constant A whole transpose, so this constant will come outside directly, and this will become A transpose. A plus B whole transpose is nothing but A transpose plus B transpose, and AB whole transpose, this will follow reversal law. What is reversal law? Reversal law is B transpose A transpose. Okay, all right. ठीक है, this you all know, equal matrix you know, commutative you know, multiplication of matrix, scalar by matrix you know. Okay, now this is actually very important. This was asked in CBSE 2023, right? Let me just show you with the help of the example, right? Let me just show you this with the help of the example. Suppose a matrix is given, let's say a matrix is given, yes, A is nothing but 2 3 0 1, and it is given that A is nothing but P plus Q, where P is given as symmetric and Q is given as Q symmetric, right? And they are asking you, what is your Q? Find Q. So basic, this is your question. I have created a question just like the replica of CBSE 2023 TY. Right? So let's understand first the concept. Try to answer this question. Okay. All right. So now symmetric matrix is such matrix where the a matrix is called a symmetric matrix. If you take transpose of it, you will get the same matrix. So if it is the case, you will call it as a symmetric matrix. Understood? If a matrix is giving the transpose of that matrix is given minus A, so this is not a symmetric but a skew symmetric now. Okay, right? So yes, if A transpose is coming out as A, that is symmetric. If A transpose is coming out as minus A, A nor minus A, then it is neither symmetric nor skew symmetric. As simple as that. Okay. So I hope the definition is clear now. Okay. Now what the property says that any square matrix can be written down as symmetric and symmetric and skew symmetric. How? So that's what they are saying. A is nothing but half of A plus A transpose. This is nothing but your symmetric part, right? Plus half of A minus A transpose. This is your skew symmetric part. So this will be your P. This will be your Q, right? A is equals to P plus Q. Let me just shift a bit so that you can see it. Okay. So yes, can you, yeah, it is already written. A is equals to, this is symmetric part, this is skew symmetric part, right? Now, if they are asking you skew symmetric, 1 by 2, 1 by 2, and you will be having 2, 3, 0, 1, right? Minus, you need to write A transpose, so 2, 3, 0, 1, right? You are done. This is your half A minus A transpose. That's it. And if you wish to write skew symmetric, P matrix, half A plus A transpose. Okay, clear? Will you do it? Will you do it if they ask you in the examination? Okay, now determinant. Let's directly talk about this. This and this. Three things are absolutely important. Okay. First is area of triangle. So please do not forget to apply the modulus. Please do not forget modulus. Area of triangle is nothing but modulus of half of x1 y1 1, x2 y2 1, x3 y3 1 in your determinant, where x1 y1 is first vertex, x2 y2 second vertex, x3 y3 third vertex. Right? If 3 points are collinear, then triangle will become 0. That means this determinant will be equal to 0. Now let's talk about so many. Let's understand this property in detail. Okay, so the very first property, let me write A times adjoint A will be equals to adjoint A times A will be equals to determinant AI. This is the first property. Second important property is determinant of adjoint A will be nothing but determinant of A raised to power n minus 1. Third very important property, determinant of KA, tell me, n, okay, and determinant A. Okay, all right. I guess these three are absolutely important. These three properties are absolutely important. And then we have determinant of A inverse 1 upon determinant A. Right? Yes. Yes. Clear? All these properties for determinant are clear. Okay. All right. And inverse of a matrix. So you know A inverse is equals to adjoint A upon determinant A. What is adjoint of A? Cofactor transpose. Okay. All right. Clear? So this, you will definitely see a question related to inverse matrix. Have you practiced inverse of a matrix? Okay, you want some more properties? Okay, all right. Yes, actually, Gray finder, yes. So adjoint of A ka determinant, if you wish to look, that will be determinant A raised to power n minus 1 square, right? But this is, I don't think so. So double adjoint, determinant of adjoint of A. So determinant A raised to power n minus 1 square. Okay. Yes, but it's great. It's actually good that you asked it, but I feel that this will be too tough for your CBSE. But still, you never know. One question may surprise you. So yes, that's it. This though we have already done. A inverse determinant is 1 upon determinant A. A inverse is A. Now again, can you see reversal law? AB transpose I told you is B transpose A transpose, and AB inverse will be nothing but B inverse A inverse. I hope that this property is clear to you. Okay. All right. Yes. Now let's talk about area under curve. For multiple situation, you will be having multiple answers. Suppose you are having like this above x-axis. So simply you have to integrate fx from A to B. This is clear. I hope this is not having any problem. Okay. Suppose you are having this curve, which is actually, so you this area, right? So this is C, this is your D. So from C to D, you have x in terms of y. So function of y dy, basically. Are you getting my point? You have to calculate the value of x in terms of y, and that complete y terminology you have to put with respect to dy you are integrating. If your graph is completely below x-axis, that means definite integration will give you negative answer. So you have to take mod of it to make it positive. Okay. Now can you see this graph is half above the x-axis? So this area from A to C, from A to C will give you negative result. So from A to C you have to take mod of this, right? Plus, now have a look. Okay, so that's why this is mod of A1 but simply A2. Fourth graph, no. Okay, differential equation. You know order of a differential equation. That means how many times your y has been differentiated. So suppose you are having d3y by dx2 plus dy by dx plus y is equals to 0. So can you see your y has been differentiated maximum times t. So that's why your order will be higher order differential is 1. So that's why your degree is nothing but 1. Okay. Yes, yes, yes. We are almost done now. Only yes, 5 minutes we will be done. Okay, do not worry. Okay, now yes, one student was asking that please, ma'am, tell us that how to identify the differential equation. Yes. So when I was a student, please give me 1 minute. I want to talk about it. When I was a student, I used to be clueless. I used to be absolutely blank when I used to see differential equation. I used to be absolutely blank. That now what to do? I was like, somebody please come. Is it variable separable or is it there? I mean, what to do? I was not able to think. Then I realized that this is a rule out game. So you just keep your fingers like this. Variable separable, homogeneous, linear differential equation in x, linear differential equation in y. So I know only four. So what I used to do is I used to differential equation and think about is it a variable separable? I used to try to separate y terms on the left hand side, x terms on the right hand side. Yes, yes. How to differentiate between homogeneous and linear? Yes, differentiate by looking at that. You won't. That's what I am telling you. That's what I am telling you. So I used to try. I used to like solve it. I used to make left hand side y terms. I used to try to put left hand side y terms and right hand side x term. But I used to fail. Then I was like, okay, variable separable cross, right? So I used to try and then fail. Okay, that means variable separable not working out. Then okay, then what I used to do is I used to calculate the value of dy by dx. Suppose it is having y square plus x square plus xy. This is your differential equation. Now what I used to do is I used to take forcefully. Acha. Okay, one is actually, let me tell you the method number two, very easy method. If you are unable to differentiate between homogeneous and linear, be careful. Okay, all right. So just put y is equals to vx. Forcefully put y and then see what happens. The moment you put y is equals to vx, it will become v square x square plus x square upon this is vx and x. Right? Forcefully put y is equals to vx. Even if you are not sure, put it. Can you see x square and x square out? Now, can you see the whole expression dy by dx is nothing but in terms of what is v? V is nothing but y by x. Your whole expression has become dy by dx has become in terms of y by x. Okay. All right. Okay. Who was asking? Who was asking? Yes, Black was asking. So Black was asking how to differentiate. So you just assume. You assume that yes, this is the homogeneous. And I'm gonna put y is equals to vx after calculating by dx. The moment I put y is equals to vx, that means this is a homogeneous equation. Now to solve it. If not, then try to find out linear differential equation. You know how does your linear differential equation in y look like? Dy by dx plus py is equals to q. P and q are function of y. Now let us revise one more time. So yes, variable separable, y and x are separable. Homogeneous is dy by dx is a function of y by x. Linear differential equation looks like this. You don't have to solve this will be a linear differential equation in today's paper. I am very sure. Right? So how to find it? Find it factor e raised to power integral of p dx where p is nothing but function of x. Right? And then this is your final solution. Y multiplying integrating factor is equals to integral of q multiply integrating factor plus p. Okay. All right. Yes. Now last thing, vector 3D and probability 3 topics are left. Okay. So yes, distance between or magnitude of a vector P2. P1 having x1 y1 z1, P2 having x2 y2 z2. So distance formula, you know that. Position vector, suppose you are having a point P whose position vector is xi cap, yj cap, zk cap. So magnitude of OP is nothing but square root x square plus y square plus x square. Okay. Now this is very important. So the moment you are having AB vector, how to form a AB vector, an AB vector. So AB vector is nothing but position vector of B, that is OB vector minus OA vector. Reverse order, please don't remember, please do not forget. Okay. All right. Section formula you know, midpoint formula you know, triangle law is this. A and then B in the same direction. Can you see? And this is the final A plus B. Parallelogram law is also like this. A, this is your B, this is A plus B, right? And this is the basic vector algebra laws, which you can just where will we use section formula? So they will directly give that the ratio. Okay, section formula questions they will give you. Okay, so you have got a point A, you have got a point B, and 3 comma 2 comma 5, and this is 4 comma 3 comma 7. Let's say so there is a point R on the line joining A and B, which divides in 3:1 ratio. You are looking for position vector of R vector. Okay, how do you solve it? Tell me. So 3 times this vector. 3 times 4i cap plus 3j cap plus 7k cap. Right? Plus 1 time this vector. So 1 times 3i cap plus 2j cap plus 5k cap. Whole upon 3 plus 1. This is your section formula. Basically, 3 times b vector plus 1 times a vector upon a 3 plus 1, 4. Right? This is your b vector. This is your a vector. Now you solve it, you get it. So this is your OR vector, which is position vector of R vector. That's how your situation is. Okay. All right. Now dot product A dot B is equals to AB cos theta. Dot product becomes 0. Where is it? Where is it? Dot product becomes 0. Yes. Dot product becomes 0 if two vectors are perpendicular. It is very important. Projection is also important. Projection of A vector on B vector. Who is going to tell me? Projection of A vector on B vector. A dot B upon B vector. A dot B upon B vector. Yes, foot of perpendicular. Okay. Okay, I remember it. Right? Now cross product A cross area of parallelogram. In area of triangle, half A cross B, A cross B, right? And if A cross B is 0, what does that mean? A is parallel to B. Okay. Please do not forget to take magnitude in the end while calculating area of triangle and parallelogram units in the very end. 3D geometry, 3D geometry, yes, 3D geometry. In 3D geometry, what is important? Distance between two skew lines. Let me just tell you this. Okay, all right. Okay, let me just have it. So R is equals to, this is one vector plus lambda times this vector. Okay, this is A vector, this is B vector. Second line is R is equals to, this is A1, this is A2 plus lambda times this is B1 and B2 vector. Right? You know that we are having two lines. A1 is point on the first vector, A2 is the point on second vector, B1 is this parallel vector, B2 is parallel vector. We are looking for what? We are looking for shortest distance between these two lines. Okay. The shortest distance, who is going to tell me? A1 vector. It will be there. Definitely shortest distance will be there. B1 cross B2. That means cross product between parallel vectors upon magnitude of the same B1 cross B2, right? So you just have to calculate how many things? Only two things. Yes, only two things. First is A2 minus A1, then B1 cross B2. Once you are done with that by the determinant method, by the way, so you just need to plug in the values and you are done. It is not that difficult. Okay, so this is your shortest distance between two skew lines. Now, the shortest distance between parallel lines. Okay. Yes, foot of perpendicular. Srinikesh, yes, I'll be telling you after this. Okay, so you are having two lines which are parallel. So now you are having A1 point. This is A2, right? So the equation will be R is equals to A plus A1 plus lambda B, because yes, and R is equals to A2 plus lambda B. Understand this, that both the B vector are same because they are parallel lines. So A2 minus A1, right, cross B vector. We are having B1, B2, no B1, B2 because parallel lines hai. This is also B, this is also B. Upon magnitude of that B. We need to find what? Cross product between A2 minus A1 and B vector. So this is distance between parallel lines. Okay. I hope that you remember this formula. Why is ma'am shaking? So I am taking from the home setup. Now I am taking this session. I'm not in the studio. So that's why maybe I'm writing. So the table is moving. That's why a little bit here and there. But the point is learning is important. है ना? Yes, now that student was asking na so many times. Let me just tell you, maybe you all get this question in your examination. So suppose you are having a point 1, 2, 3 and you are having a line x minus 1, y minus 0, z minus 3 upon let's say 3 and then we have 1, then we have 2. Okay, we are looking for foot of perpendicular. So we are this is point P and this is your F. How to find parallel or not? By looking at it. We did last night. So let us say this is your 2i cap, 3j cap plus 4k cap plus lambda times k cap plus 3k cap, right? And the second line will be, so here's something 8j cap plus 3 to the 6k cap. Now, can you see that these two directions are exactly same, proportional? So that's why these two are parallel lines, right? Okay. Okay, now let's get back to the foot of perpendicular topic. Foot of perpendicular topic. So a point is here, and from this point you drop a perpendicular on this line. Line is also given to you. You are looking for F, right? So for F, what you have to, step number 1, you have to assume a point F in terms of lambda. So F will be, tell me, then y is equals to lambda, and then z is equals to 2 lambda plus 3. Second will be calculate PF vector or coordinates of PF. What would be PF? Who is going to tell me? So PF will be nothing but coordinates of PF will be, so this is 3 lambda plus 1 minus 1. 3 lambda. Then we are having, so 3 lambda plus 1 minus, then we are having lambda minus 2. Then we are having 2 lambda plus 3. So 2 lambda plus 3 minus 3 will be 2 lambda only. Now can you see P is perpendicular to this line, and this line has a direction 3, 1, 2. So PF dot product with j cap plus 2k cap. That means direction of line would be 0. That's how we find the value of lambda. Shall I solve it for you? So 3 lambda into 3. Then we have plus 1 times lambda minus 2. Then we have 2 times 2 lambda. Right? And this will be 0. Get the value of lambda. And now finally put the value of lambda in F to get the value of F. Yes? Clear? If you haven't liked the session, why you didn't like the session? Okay? I have not slept. You know what? I have not slept at all. I am like this only. And after this session, I am going to sleep and I will be very nervous. I won't be able to sleep actually. I'll be like, my students, what are you doing, guys? After you come, you have to tell me how was your paper. Okay. Okay. And then maybe I would be able to sleep. Okay. So vector 3D is done. So this was the last thing. Now I know that you guys want direction cosine and direction ratio. Okay. So let me just tell you that, okay, you are having a line. A line makes an angle alpha, an angle beta, and an angle gamma with the x, y, and z axis. Gamma is by z axis, right? So cos alpha is equal, cos alpha, cos beta, and cos gamma is your DC. And the value is allotted. L is equals to cos alpha, M is equals to cos beta, and N is equals to cos gamma. Vanix, no need to find intersection point in shortest distance. No. The point is, okay. No, Vanix. So basically, Vanix is asking that, ma'am, okay, you are saying that you are finding shortest distance between two skew lines. You know what are skew lines? Which are neither intersecting nor parallel. If the lines are intersecting, that means shortest distance will. Okay. All right. So this is your direction cosine. You can see. And okay. And yes, suppose angle is 30 degree, beta is 45 degree, and gamma is 60 degree. Can you tell me? Can you tell me cos alpha or direction cosine? Who is going to tell me? So root 3 by 2 because cos 30 degree, 1 by root because cos 45 degree, and a cos 60 degree is 1 by 2. Right? Okay. This is your direction cosine. Now this is your direction cosine. What is direction ratio? So you multiply, it will become your direction ratio. So dr, if you wish to find dr, multiply 2. You are going to get root 3, 2 by root 2 and 1. If you multiply 1 in this, so this is going to be still your direction cosine, but this is your direction ratio as well, both. Yes, okay, okay. Yes, yes, yes. Okay, all right. And now Cartesian, so vector form and Cartesian form. Vector form and Cartesian form, if you have to convert. Okay. So suppose question is given to you that line passes through 3 comma 1 comma 1 and parallel to a vector which is 3 cap plus j cap. That's it. Okay. You need to find vector form and Cartesian form. So first, my finding Cartesian form. Okay. Okay, let's find out Cartesian form. So this is your point. So x minus 3, y minus 1, z minus 1 upon. Now this is direction. X component is 3, y component is 1, z component is 0. This is your Cartesian form. This will be your lambda, right? Okay. And vector form, who is going to tell me vector form? Vector form will be r vector is equals to, here you have to write the point. What is the point? 3 cap plus j cap plus k cap plus mu times, where is the direction? This is the direction. 3 cap plus j cap. That's it. Okay. So definition. Conversion. Now conversion. Please, one more thing. I feel that, okay, maybe this conversion. Please, x minus 1, y minus 2, z minus 3. And this is, yes, let's say 2x minus 1. And yeah, upon 2, upon 3, upon 1. So this is function form. And you need vector form. Convert it into vector form. Okay. So clearly that this line passes through which point? Who is going to tell me? 1 comma 2 comma 3 and is parallel to which line? Parallel to which vector? 2i cap, 3j cap, k cap. So now I know r vector will be point plus lambda times direction. What is the point? 1 comma 2 comma 3 I cap plus 2j cap plus 3k cap, and lambda times direction is this. Conversion is also very easy, right? Lambda is, so we have written lambda only. Yes. Okay. Now application of derivatives AOD. Okay. If your f dash x is greater than 0, your function is increasing. If your f dash x is less than 0, your function is decreasing. Okay. This is very simple. Okay. All right. Now maxima and minima. Maxima and minima, what you need to do is, so there are two ways about it. Method number 1, understand this nicely. So first thing is you have to find f dash x equals to 0 and find all the values of x. These will be your critical points, right? Critical points. Now what you need to do is you need to draw a number line, and suppose x is equals to 2 comma 3, you are having 2 and 3 points. Now you need to check the sign of your f dash x. Sign of f dash x, right? About x equals to 2 and 3. In the neighborhood of 2 and 3. Before 2, what is happening? After 2, what is happening? Before 3, what is happening? After 3, getting this sign, right? So that means f dash x is positive. So can you see f dash x positive? F dash x positive means increasing. So now your graph, fx graph will be increasing. Here your fx graph will be decreasing. So you are going to get minima. That means if your f dash x sign changes from minus to plus about your critical point, that means you're going to get a minimum. But can you see now this is your because positive. Before 2 it is positive. So if your f dash x changes sign from positive to negative, can you see positive to negative? So positive to negative, you are going to get a maximum. I hope that this is clear. Okay, this is method number 1. Now method number 2. Method number 2 mein again, your first step is very same. F dash, make f dash x equals to 0. Find critical point. Okay. Now you know the f dash x. Now find double dash. If your f dash x becomes positive at x equals to, that means positive means minima. Double derivative test. Positive means minima. If your f double dash x becomes negative at x equals to 3, by the way, for example, we don't know. So we are going to get maxima on that. Okay. All right. So this was the last thing. This was the last thing of the session. AOD is done. And yes, from my side, I wish you all the best. Be confident and show the confidence in your paper. You will do absolutely good. Be ready for 1 or 2 questions which might be a surprise element for you. Do not get scared. It happens. Every time it happens that 1 or 2 questions may be surprise element. Do not focus on that. Focus on what you know. Play with your strength. And then you never know. Maybe the surprise element also will be easy. So in the very end, you can solve those surprising questions. Okay. All right. We didn't finish probability. Kya? We didn't do it. We didn't do probability. Okay. Yes. Oh, oops. Yes. Probability may let's do it. Let's do it. Okay. Let me just, yes, probability. Okay. Okay. Yes, this is your probability. No. I am here. Come back. Probability. Yes. So probability may, you know the conditional probability. So conditional probability says that probability of E where F has already occurred. So that is probability of E intersection upon F. So that is one formula which is important. Okay. The next formula which is important is, now the same formula. If I wish to calculate F, how do I do that? So if I wish to calculate the probability of E intersection F, so that will be probability of F multiply probability of E intersection F. Right? This is it. Okay. Now, what happens when 2 events are independent? E intersection F will become PE, PF. Okay. All right. Very important thing. Probability of F will become probability of E if E and F are independent. Right? So how do you solve it? Let me just tell you. If somebody asks me what is of A given that B has already occurred when A and B are independent, so I just remove B. This is the answer. That's how we do it. Understood or not? So this is probability of E slash F will become probability of E because E and F are independent. Okay, that's how we remember. Okay, I hope this is clear. And yes, this multiplication theorem of probability is nothing but the same, only conditional probability and multiplication probability are same, right? And then Bayes theorem is absolutely important. So here is the Bayes theorem. Have a look. Bayes theorem says that if you are looking for probability of A, right, E1 slash A, so that will be probability of E1, probability of A slash E1. And in the denominator, the total probability will be there. Okay. All right. So Bayes theorem, please, so you will get a question from Bayes theorem for sure. And if not, then independent events. If not, then total probability theorem. These 3 possibilities are there. Okay. All right. Yes. So I'll be taking your leave now. I wish you all the best. And once you come back, I'll be sharing a poll on Telegram channel. And yeah, so I'll be sharing a poll on Telegram channel that how was your paper. That's how we are going to communicate. And we'll meet you super soon for the J preparation as well. So yes, all the best, all the best. For case study, we need to write steps. What does that mean? Step means what? Yes, step wise. Yes, you need to write all the steps, the normal subjective solution. Okay.